Hello everyone. Welcome to the demo of Zscaler's Breach Predictor. Today, I'll be walking you through the Breach Predictor console. You are at the landing page of the Breach Predictor console. The first thing you will notice that we are today ingesting two data sources, the ZIA web logs as well as sandbox data. When you look at the Breach Predictor console, you'll see the probability of breach. For this particular environment, which is our demo environment, you can see that the probability of breach is 30%. You can click in and understand why the breach is 30%. And this explanation and this AI-powered explainability tells you that the probability is determined by this backdoor category, which is observed at the initial access stage of the MITRE attack matrix impacting one user. Not only that, but also you have three malwares, Smash Browser, Radamanthus, and Luma, which are impacting your environment. As you move down, you can actually see the total number of users that are in your environment. In this case, you can see that 152 users are secure and about 4 of them are at risk. This basically then moves towards the different stages of where the breach is and where the risk is. Most of the users in this environment are in the discovery phase and the compromise phase. And also, we talk about the different categories or threats that have been impacted in your environment. And as you can see, there are various malware families which have been impacted here. We can select this data for the past 30, 60, 90 days, or even a custom date range varying up to a year. In this case, we have looked at data from last year, September, to this year, September. To further go ahead and understand what's happening in your environment, a SOC analyst can click Explore and try to understand all the threats within the environment. These threats can be organized based on the severity of the score. The severity of the score is determined by the type of threat and its severity, the number of users it actually impacts, as well as the farthest it has reached the MITRE attack matrix. In this scenario, let's go ahead and evaluate what's happening with Radamanthus. If I click on Radamanthus, it'll actually tell me the number of users that have been impacted. As you can see over here, we have about 1 user impacted by this particular threat. A SOC analyst can further go ahead and click on the user and try to understand the different transactions which have occurred in the user environment. There are 2 types of transactions which have occurred. One is at the resource development stage. The second one is at the initial access stage. To look at all tactics, you can just click all tactics. If the SOC analyst needs to get further details, they can click on the transaction and actually see the details. There are 4 questions typically that the SOC asks. Who did it happen to? What happened? Why did it happen? And how did it happen? The who did it happen to in this case is Satakshi Dubey. We can see that we have the client IP, the proxy IP in here as well. What happened was Radamanthus, which was a threat, as you are aware. There was some sort of a general browsing which occurred, and then the policy, why is based on the policy name. In the next 2 weeks, we will have more details about what policy basically impacts this. And then how did this happen? Basically, the user got redirected to this particular URL, and this is a miscellaneous or an unknown category URL, and this is a destination IP. A SOC analyst can effectively copy this and search for this data across their SIM if there are any other users which are impacted across the board. They can also go ahead and click on Download CSV, which will download the entire transaction so that they can actually go ahead and triage it further. We are providing all the information in a single click to provide better context to triage this faster. So reducing the time to triage and being able to anticipate what's happening in the environment. From here, if we go ahead and click back on the threat itself, we want to understand how far has this threat traveled in the MITRE matrix. You click on the attack path and you can see that there are three effective stages. One is the actual path, which is what is happening in your environment. The second one is the possible path, which is what happened in your environment, which led to the actual path. And then the probable path, which is what are the chances of this happening in your environment in the future. So if you go ahead and click on the AI assist piece, you can get details. So this is a LLM-based model, which not only tells you what Radamanthus is, but also gives you details as well as the IOCs. For example, in this case, it's telling you that Radamanthus actually leveraged this particular IOC and went ahead and was in resource development, which further created an initial access or a compromise in this case with the with a redirect to comma.fr/cache/query.js. Now from here, we want to understand how did the user actually get to this particular website. And if you look at it, it tells that Radamanth may have had a spear phishing link or attachment to gain entry into the network. So not only it's telling you what happened, but possibly how it could have happened. Now, to further this, you can also click on the probable. The probable is effectively all the details on what are the next step which could happen. Right from execution to persistence, running in registry keys, to credential access, discovery, lateral movement likely, automated collection, and then command and control. We are able to provide you a understanding of why, what are the chances of your data getting exfiltrated. In this case, you can see that it's saying it's a 45% of moving from command and control to exfiltration, as Radamanth malware has infected and no users at this point in time. The whole goal of this particular product and this particular screen here is to anticipate and prevent future attacks. Based on this, we will be providing you recommendations on what are the changes, the policy that you can make to prevent this attack itself. Likewise, both the AI assist part as well as the SOC triage piece, we want to make sure that we're able to visualize the attack path as well as provide you guidance on how to stop this attack itself. The other piece in here is if you look at the threat landscape, along with this product, you get Zscaler's Threat Lab curated threats at your fingertips. You can look at you can sort this particular data by the severity. You can sort it by the engine, whether it's firewall, hash, in the inline YARA rules, URLDB, or WAF, and also the product. Today, we are providing you ZIA and ZPA. Or if you yourself know what the name of the product is, for example, Win32, you can actually look at all the exploits associated with Win32. If you click on this particular product, it will actually take the threat library for threat labs, and basically click through it and get more details around the kind of detections, as well as the severity and the content in the detection ID and the score associated with each of these threats. If you go to the My Profile page, the My Profile page effectively gives you what is your current SKU, your cloud ID, and your organization ID. And as a customer, we've also provided a capability for you to submit any reports or any support issues via the product directly. And this way we can address any issues or any support challenges which the customers have. With that, this is the end of the demo. I do want to highlight that the value from Zscaler's breach predictor is comprehensive visibility, ability to see the attack and the malware mapped to the MITRE attack matrix. Second is visualizing the attack path for fast remediation. And the third one is anticipate and prevent any future attacks, leveraging predictive security, especially the policy recommendations, which will be coming shortly. Thank you so much for your time and listening to this.